Welcome to EPG Pathshala. I am PG Padma Gauri, working as an Assistant Professor in Faculty of Engineering, Avinash Lingam University, Coimbatore. Today we are going to discuss about acoustic and sound absorption. The word acoustic is originally derived from Greek word meaning to hear. Hence, acoustic is defined as the science of sound and as such. It discusses the origin, propagation and auditory sensation of sound. When a sound wave strikes, part of its energy is absorbed by friction, part of its energy is transmitted and their main part of its energy is reflected. So the objective of the acoustic and sound absorption to know about the details of audible range of sound and its properties, to analyze various materials used in building construction and its acoustic properties, to enhance sound qualities, provide sound absorption materials in construction of building, methods to enhance the acoustic in building and eliminate the noise. Acoustic is nothing but a sound produced when part of the atmosphere is compressed suddenly. This compression would have retained stationary at that place only. Air was not elastic, but due to the elasticity of air, the particle originally distributed in turn disturbed the neighboring particles. Ultimately, the compression is propagated or spread away from the source. Sound thus travels in form of waves, and when these waves come near to our eardrums, we feel sensation of hearing. Following are the important facts in connection with the sound. The sounding body which throws the sound waves in the state of vibration. If vibration of the sounding body die out, the sound emitted by the sounding body will also die out. It is absolutely necessary that for a sound to be heard by our ears, the sound body and the ear must be connected by an uninterrupted series of portions of elastic matter. The physical state of matter, namely solid, liquid or gaseous, is very important for sound transmission. Presence of some matter is required for the transmission of sound. Sound cannot travel in vacuum. The sound waves are longitudinal waves and latitudinal waves, and hence each particle of the medium through which sound wave is proceeding moves backwards along the line in the direction in which the sound wave is traveling. Velocity of sound. The speed at which the sound waves travel or pass through any medium is termed as sound velocity, and it depends on the nature and temperature of the medium through which sound travels. The table shows sound velocity in different medium. Some of the mediums are atmospheric air, and the sound velocity at 20 degrees centigrade in meter per second is 342. Granite sound velocity 6400 meter per second, concrete 4000 meter per second, copper 3900 meter per second, brass 3500 meter per second, rubber it's very less 40 to 150 meter per second. The important facts to be remembered in connection with velocity of sound are the time required by sound wave to travel from one place to another quite appreciable. The velocity of the sound in air is affected by the amount of moisture in the air, temperature of the air and intensity of the wind. The velocity of the sound is independent of the frequency or pitch of the sound. It can be seen from table that sound travels much faster in solids and liquids than it does in the air. Frequency and intensity of the sound. Frequency or pitch is defined as the number of cycles which a surrounding body makes in each unit of time. The greater the number of cycles, the higher will be the pitch. The intensity or loudness of the sound is defined as the flow of sound energy per unit of time through unit area. Thus, frequency and pitch is a measure of quality of the sound, where the intensity or loudness is a measure of quantity of the sound. The audio frequency scale covers a wide range of varying from 20 cycles per second to 15,000 cycles per second. Lower limit for normal average human ear can hear. The upper limit of the frequency depends on the age of the person and his physical fitness to receive the sound. It can be noted that intensity of the sound in decibel and frequency of the sound in cycles per second are physical quantities which are defined arbitrarily. The table shows some typical sound levels. Source or location and sound level given in decibel. Threshold of audibility, it is 0. That is, it is said to be inaudible. Quiet whispering, it's 30 decibel. Conversation at a distance 1 meter is 40 decibel. Quiet speech 50 decibel. Loud noise 120 decibel. City traffic and busy street is 70 decibel. Reflection of sound. Convex surfaces tends to spread the reflected waves. Hence, convex surfaces may be used with advantages to spread the sound throughout the room. The study of law of reflection of sound helps in select proper shape of the room with regard to this distribution of the sound in that room. The assumption that sound are reflected in the same manner as light is true only for a limited circumferences, and hence great caution should be exercised while applying the law of reflection of sound. When a free sound wave traveling through air strikes a uniform, large, solid, plane surface, it is reflected in the same manner as that of light. It is shown in figure. The angle which is the incandescent sound makes the plane surface is equal to the angle which is the reflected waves to the surface. Reverberation. It is quite clear that some interval of time will be required for the sound energy to convert into another form of energy. This transformation is usually brought about by friction between the sound wave and air particles, as well as sound and surfaces with which it come into the contact. Naturally, the more the friction, quicker will be the transformation. The gradual process of transformation operates over a certain interval of time, and this is known as reverberation. Now, m is equal to 10 log I1 divided by I2 base 10. It is found that a normal person speaks, m value is equal to 60 decibel. The time of reverberation is thus defined as the time required by the reverberant sound to decay to 1 millionth of its initial value. This naturally corresponds to the drop of 60 decibel. Reverberation times and acoustic is given in table. If the reverberation time is 0.50 to 1.50, acoustic is said to be very good. And if the reverberation time is above 5, the acoustic is very bad. So, the optimum reverberation time will depend on the use of the room. The table gives the relation between the reverberation time and acoustic of the room. If the reverberation time is too long, it results overlapping of the speech. We cannot hear clearly. If it is too short, producing the effect of deadness. We have the optimum reverberation time for particular halls. For example, chamber music, the optimum reverberation time in seconds is 1 to 1.4. For cinema, it is 0.6 to 1.2. Orchestra, 1.2 to 4. Drama performance, 0.8 to 1.2. So on. Noise and its effect. Noise is defined as an unwanted sound, and it may be due to frequency of the sound or intensity of the sound, or both. Noise due to high frequency sound is more unpleasant and harmful than that due to the low frequency. We have two types of noise. One is indoor noise created by adjacent room or same room in a house. Outdoor noise created from nearby streets and other source from the outside. Indoor noise elimination. Improvement in working methods. A working method creating less noise may be adopted. Acoustical treatment. The walls, floors and ceiling should be provided with sound absorbing materials. Personal protective devices. It is possible to reduce a noise to some extent of 20 decibel to 30 decibel by using personal protective devices like headphone, earplugs, etc. Absorption of sound. When a sound wave strikes surface, part of its energy is absorbed by friction, part of its energy is transmitted, and remaining part of the energy is reflected. But as reverberation directly depends on the loss of energy of the sound wave due to friction, it is of greater importance. This property of surface by which sound energy is converted into other form of energy is known as absorption. Absorption coefficient of the surface indicates the degree to which these surfaces affect the absorption of sound. It is thus the ratio of energy absorbed by the area to the energy striking the area. The value of coefficient of absorption will depends on the frequency of the time. The table gives the values of coefficient of absorption for some of the common surfaces. For example, open window absorption coefficient per meter cube is 1. That means it will not allow any sound, it will pass all the sounds. Ventilators 0.1 to 0.5 meter cube. Glass against solid surface it is 0.03. Marble it is 0.01. Polywood metal it is 0.01. These value corresponding to the normal frequency of 500 cycles per second. It may be noted that the coefficient of absorption for an open window is taken as unity. Sabin's equations. Professor W.C. Sabin of Harvard University, USA carried out a number of experiments in rooms of different sizes and he was able to establish the following formula. T is equal to 0.16 V divided by A. T is equal to reverberation time in second, V is equal to volume in meter cube, A is equal to total absorbing power in meter cube. Total absorbing power is nothing but absorption of individual objects. Since V and A can be worked out from the planes and specification of the structures, it is possible to design the structure of any desired value of time reverberation. Absorbent materials. Most of the common building materials are absorbed to small extent and hence for better acoustical requirement, some other materials are to be incorporated on the surfaces of the room. Such materials are known as absorbent materials and they help a great deal in making the room acoustically good. The important facts in the absorbent materials are: an ideal absorbent material should be economical in constructions and maintained, waterproof, powerproof, sufficiently strong and good in appearance. Noise level of the room provided with the absorbent material is considerably reduced. In the hall treated with absorbent material, speech can be heard clearly and music can be fully enjoyed. All the absorbent materials are found to be soft and porous. They work on the principle of that sound waves penetrate into the pores, and in this process, sound waves are converted into other form of energy by friction. The absorbing capacity of the absorbent materials depends on the thickness of the materials, its density and frequency of sound. The acoustic properties of the absorbent materials are considerably changed by their mode of fixing. Suspended absorbers in the form of individual cones may be provided in the ceiling to make the hall acoustically good. There is no royal road for making a particular room acoustically good. It mainly depends on the ideas of the engineers or the architect. Each case is to be studied separately, and after proper thinking, suitable absorbent materials may be specified. Great care should be exercised while prescribing the converting for an absorbent material so as to improve its appearance. It should be remembered that in a big hall, audience is a major absorbing factor. This is especially true in the high frequency zone. Hence, low frequency absorbing materials should be provided to achieve optimum reverberation time over a wide range of frequency of sound. Types of absorbent materials. Various types of absorbent materials are available in the market under different trade names. The value of coefficient of absorption is supplied by the manufacturer. The choice of the absorbent materials should be made after carefully considering various factors such as appearance, cost, workability, flame resistant, durability, light reflection, etc. The following are the some common types of absorbent material. Higher felt. This material was used by Professor Sabin in his experimental work. The average value of coefficient absorption is 25 mm thick and hair felt is 0.60. Acoustic plaster. This is also known as fibrous plaster and it includes granulated insulation material which is mixed with cement. If quantity of cement is more than required, the plaster will not have sufficient pores to become effective for acoustics. So the coefficient of absorption varies from 0.15 to 0.30. Acoustical tiles are made in factory and sold under different trade names. The absorption of sound is uniform from tile to tile and they can be fixed easily. Because of high cost, they are most suitable for rooms in which small area is available for acoustical treatment. Straw boards or the materials can be used as absorbent material with the thickness of 13 mm and density of 0.24 gram per centimeter cube. It possesses a coefficient of absorption of 0.30 at 500 cycles per second. Compressed fireboard. These materials may be preferred or unpreferred. The average coefficient of absorption for the compressed fireboard is 0.30. Compressed wood particle can be preferred and it can be used with the painted format. With the thickness of about 13 mm, the average coefficient of absorption is 0.40. Perforated plywood. This material can be used forming composite panels with mineral wool and hardboard. The average absorption coefficient is 0.75. Quilts and mats. These are prepared from mineral wool or glass wool and are fixed in the form of acoustic blankets. The coefficient of absorption is based on the thickness of the mats. Conditions for good acoustic of an auditorium. The following conditions should prevail in an auditorium possessing good acoustical property. The initial sound should be of adequate intensity or loudness. The quite obvious, as it is impossible for a speaker to be heard over a long distance without the help of sound amplification system. The sound which is produced should be evenly spread over a whole area covered by the audience. If this condition is not satisfied, conditions tending the formation of echoes will be established. The initial sound should be clear and distinct so that there is no possibility of distorted speech. For a hall to be used for music, the initial sound should reach the audience with the same frequency. All undesired sound should be reduced to such an extent that it will not interfere with the normal hearing of music or speech. Factors to be considered in the acoustical design of an auditorium. Volume. The volume should be enough and it is decided while keeping the view of intensities of sound likely to be developed in the hall. Hall of small volumes are useful for weak sound. Shape is very important consideration in the acoustic design of an auditorium and it involves geometrical aspects of the hall. The paths followed by reflected sound waves are traced and concentration of the sound wave. Concave walls are not good for acoustic purpose as they tend to concentrate sound waves. Plain walls are better, but convex walls are excellent and are excellent used to reduce the possibilities of echo in the minimum extent. Sound absorption. Adequate absorbing surfaces should be provided in the hall to control the reverberation. As a matter of fact, the acoustic design of an auditorium will be incomplete without the provision of such a surface. Careful study of the hall should be made before recommending the type of the absorbent materials and its location in the hall. Defects of auditorium and their remedy. There should be good direct path for the sound. This will be enable the sound to be heard loudly and clearly and will avoid confusion with subsequent reflections. It should be seen that none of the subsequent reflections has the same strength as the original sound. Desired degree of reverberation sound is provided in the auditorium. Reverberation. The defect of excessive reverberation is very common in many auditoriums. The effect is that sound once created prolongs for a longer duration, resulting in confusion with the sound created next. The remedy of this defect is to correct the time of reverberation by suitably installing the absorbent materials. Formation of echoes. When the reflecting surfaces are situated at the distance greater than 15 meters or so, and when the shape of the auditorium is unsuitable, formation of echoes taken place. This defect can be removed by selecting proper shape and porous interior surfaces to avoid the echoes. Sound fuzzy. In the case of concave reflecting interior surfaces, certain spots are formed where reflected sound waves meet and create a sound of large intensity. These spots are known as sound fuzzy, and they can be eliminated by avoiding curvilinear interiors or by providing absorbent materials on focusing area. Dead spot. This defect is just the reverse of the previous one. Because of the high concentration of reflected sound at sound fuzzy, there is deficiency of reflected sound at some other points. These points are known as dead spot, and the sound level at dead spot is generally inadequate for satisfactory hearing. This defect can be remedied by installation of suitable diffusers so as to have even distribution of sound in the hall. Loudness. This defect is due to lack of reflecting surfaces near to the source of sound and excessive absorption of sound in the hall. The remedies to correct this defect consist in arranging hard reflecting surfaces near to the sound, and the remedies to correct this defect consist in arranging hard reflecting surfaces near to the source of sound and in adjusting the absorption of the hall. So it gives the optimum time reverberation. Exterior noise. This defect is due to poor sound insulation, and hence exterior noise enters the auditorium through loose doors and windows. The remedy to correct this, various components is used for the auditorium. Coming to the conclusion, the concepts of audio sounds and its properties are discussed. Various methods to measure the audio sounds and the properties of audio sounds are elaborated. The material which different acoustic properties are discussed. By using the different acoustic properties materials in buildings, the sound quality of the buildings should be enhanced. So the quality and quantity of the sound in any buildings should be perfect. Then only we get the clear sound effects. Thank you.